Hello, nerds. Let's talk about Git and GitHub. So the question I want to answer is why use Git and GitHub? Now, there's dozens of tutorials, very good tutorials, on how to use Git, from the command line, using different types of clients, so on and so forth. That's not my goal to help with that. There's plenty of ways you can get help with that. I want to explain why you would use Git. So what problems does Git solve, and also what problem does GitHub solve? Um, the target audience here is undergraduate CS majors. So why are we targeting undergraduate CS majors? Well, I'm a professor, that's who I teach. But also, the computer science curriculum, the courses tend to focus on fundamentals for computer scientists. So data structures, algorithms, binary search trees, searching, sorting, a little bit of theory, P versus NP, some different programming languages, different programming paradigms, functional, object oriented, maybe a little bit of design, maybe a little bit of teamwork in a software engineering course or something like that. But there's only 4 years, so you don't have infinite time in school, and you don't have that much time on task. So it turns out there's not always a lot of time to cover software engineering tools, but and the tools change over very quickly. But tools like Git, they solve a fundamental problem in software engineering in the same way that binary search tree solves a fundamental problem in computing, right? So even though the CS curriculum tends to focus on important problems in computing, that doesn't mean that there aren't really important problems in software engineering, and that doesn't mean that there aren't really good tools to solve those problems, right? So um, just because just because those problems aren't covered in the curriculum doesn't mean they're not important. So the first thing to think about is why people use version control at all. In other words, like, why don't we just have a big Dropbox folder? Everyone have their own Dropbox folder, and then we, like, I don't know, send versions of files back and forth. So what problem is version control really solving? Um, it's really a question of coordination and management. It's a collaboration problem that we're solving. So you might have multiple different developers all working on a project, and you have to manage multiple different branches. And I'll show you in a second a picture to explain this. So there might be a master branch, or trunk, it's sometimes called, production branch, feature branches, release, stable, etc. So let's look at it at sort of a picture here. So here we've got development on the master branch. We've also got a release branch. So on the release branch is going to be like, the 1.0 release. There's going to be like a special, commit that's, tagged on the release branch to let us know, like, this is version 1.0 of the software. The state of the files, at this moment ends up being version 1.0. But there's a lot going on in this very simple picture. So this, here's the development on the master branch. We've made a branch here from version 0.1 to a development branch. And this development branch is where we're going to do our work to get us to version 1.0. And so on this branch, we decide, what, there's this hot feature that people want. So I'm going to make a branch just for that feature. And the developer that did that works on that feature for a while, but it doesn't really work out. Maybe the testers, the quality assurance people didn't really like it. Maybe it didn't test well with users, whatever. So we work on this. It doesn't go anywhere. This branch just dies. Okay, great. We just ignore the branch. No big deal. We do a little bit of work and we're like, what? Here's another feature people really want. So we go ahead and make a branch for that feature. Now, at the same moment in time, I should mention with this diagram, time moves from left to right. So at approximately the same time that, whoever's working on this branch writes some code, maybe there's some features that we definitely know we're going to have, and then these are like experimental features that we may or may not have. Maybe these are like reach goals. So somebody does some work here, but we make this branch and somebody else gets this feature done and they want to what's called merge it back into the development branch. So at this moment, this is what's called a merge. So it's a commit where we're going to take the code from the feature branch and merge it into the code on the development branch. So essentially, whatever changes are here and whatever changes are here, right? Since at this moment they're the same. Here, this branch comes out. Here, some code gets changed. This changes and these changes, they're getting all shoved together. So as long as these changes and these changes are to different files, no problem at all. If they are changes to the same file, as long as they're to different functions in that file or different lines of the same file, we're okay. But as soon as you have changes to the same line of the same file, then you're going to get a merge conflict. And so whoever's doing this merging this feature branch back into the development branch, they have to go in and figure out how to fix those things. And that's really just like the whatever tool you're using is going to tell you like, hey, you've got a merge conflict. Here's one version, here's the other version. You can either pick one or you can create some new version that incorporates the changes of both of them. And so developers tend to try to avoid merge conflicts as much as possible. How do you do that? Well, good communication, right? You should know what people are working on. This is why there are managers. This is why there's all these different productivity tools like Trello and Slack and Pivotal Tracker and whatever else. More or less what people are working on. That's why you have meetings. So a lot of these problems can't, these are people problems. They're collaboration problems. They're not technical problems, really. So anyway, this would be a merge. And then at that point, we're like, you know what? I think we're ready for release. So we branch for release. But then the testers are testing this, and they're like, I don't know about this. There's some bugs in here, so we got to do another commit. Now the testers are happy. The quality assurance people are happy. The client's happy, whatever else. Boom. Now we're ready for this is our release, and then we can sort of put that back into the master branch, and then we repeat the process again. We branch it again back onto the development branch. We sort of like merge this back over to here, and we continue working. So that's kind of like a really brief overview. So this is really simple. There's a master branch, there's release, there's a development branch, and then there's these two features. In reality, it's going to be way more complicated than that. And I just wanted to show you, this is the link where I got this. It was a Stack Overflow question. And it's not specifically about what I talked about, but it is a pretty good picture. This is another article. This is a Medium article just making the case for why you want to have a release branch and not trying to do everything on master. It's just interesting. So if you're interested, go ahead and read it. It's not I've kind of already explained it, so I'm going to kind of gloss over it, but I did want to give you the link so that you could have a chance to check on that. Okay, so here's another way to think about this. So in this one, here we've got the branches, but now time moves from top to bottom. So the master branch, that's where a lot of the development is happening. And you can see we still have the same thing here where we have feature branches. We work on this feature. We're happy with it. We merge it back into master. That's fine. Master is basically the development branch at this point. This is showing off a couple of things. There's a release candidate branch. This means like we're pretty happy with this code. We want to see if it's good enough for our 1.0.0 release. But then there's a bunch of other commits before we finally actually have the release on this special stable branch. Why is that? Well, probably quality assurance and testing. Probably the testers found errors and had to fix it. And I should mention, what do we mean by testers? Well, at a lot of companies, not all developers do the same things. So some people are just developers, meaning they write code, and maybe they do some amount of unit testing and things like that. But the big tests, the integration tests and the big system tests and the user tests and things like that, those might be done by special people whose job is just to do testing. And the testers may fix the bugs that are identified by testing, or they may just put them into some bug database for the developers to fix. It really just depends on the company and the way they set their org chart. You also have people that do quality assurance. That's like a little bit more abstract than testing, but it's basically another type of testing with maybe a little bit closer to the business goals, the business processes that the clients are looking for. So anyway, through some amount of testing, some problems were found that were fixed and identified, and then we're like, you know what? Boom, stable release 1.0.0. Love it. Well, what's happening over here? Well, we've got a minor release candidate. Maybe somebody found a quick bug, or they found some sort of a problem for the 1.0.1. So we make this branch. We make some changes from testing or whatever else. Maybe there's a quick feature that needed to be added. Maybe there's a security update. And then boom, back onto the stable once things are stable. So the only things on the stable branch are very, very stable code. All the bugs have been found. There's no experimental features. The stable code should be as rock solid, as stable as you can get. That's why there's very few commits here. There's a ton of commits here. There's a lot of commits here. Very few commits here. The other important thing about this picture is we have these support branches. Here's the 1.0.1 support branch. Here's the 2.0 support branch. And you can sort of see what's happening, right? As we're doing our release for 1.0 and 1.0.1, we're still doing development and getting ready to get our 2.0 release candidate. what's happening there? Well, I'm running Mac OS 10.15. There are still new updates and bug fixes and security updates for 10.15 coming out right now. However, the developers at Apple are absolutely working on 10.16 because about every other year or something like that, they come out with a new version of Mac OS. Windows is going to be the same way. Any software product is going to be the same way, right? So while this 1.0 and 1.0.1 release comes out, we're going to need a support branch just for fixing bugs that only pertain to this version of the code, right? Sure, there could be a ton of new bugs added over here, but who cares? All of this stuff and these features and whatever else they've been added, this feature may have a ton of bugs. So what? For version 1.0.1, this feature isn't in 1.0.1, right? Here's a release candidate. Here's the minor release. We're not doing anything with this feature. This feature isn't in this software, so this support branch doesn't need to know about this feature. Any problems in this feature are irrelevant to people running 1.0.1 of the software. So that's really important. You're going to have some developers maintaining the current release while other developers are working on the next release. And those things are happening at the same moment in time. Without some kind of a version control system that has good support for branching, you can't really do that. So the value of VC, version control, is collaboration. You need to coordinate between multiple teams of developers, testers, QA, managers, whatever, to manage multiple different releases, features, branches, so on and so forth. Academics like me often haven't had a real job as a developer, so I haven't been a real developer. I'm an academic. I do this for a living. I make YouTube videos and teach undergraduates. So we don't always do a good job communicating to students like the actual problem that version control solves. So that's the first thing I want to do. Branching, releasing, very important. Not something you're going to do as an undergraduate, probably, if you want to set up your own Git repo, but still really important to think about. So moving on. We say that Git's decentralized or distributed as a version control system. This is different than the centralized systems that came before it. What do we mean by decentralized or distributed? And I put a link to an article here that there are nuanced differences between decentralized and distributed. Decentralized essentially means every copy of a repo is equal. There's not a hierarchy. Distributed means, while like functionally they're equivalent, there's a hierarchy, right? So like if you're, the lead developer and the main person in charge of releases at a company, your repository is probably more important than like a junior developer that's just working on experimental features. Their repository is less important than yours. So that's the difference. It's really just sort of a difference in how org charts have to be set up. But the real question we want to know, how does decentralized or distributed, I'm going to use the terms interchangeably. I explained the differences, but who cares? How do they differ from what came before, which was centralized? Well, let me tell you. So in the early days of version control, we had CVS, which goes back at least to the 80s, probably to the 70s. CVS stood for Concurrent Version System. And then SVN came along late 90s, early 2000s, and that fixed a bunch of the problems CVS had. But they basically they both had the same fundamental model as far as like centralized. So it's really easy to check out a local copy, but it's really hard to commit or check in code back to the central server. Let me show you a picture. So there was a central repository. And for open source projects, there was a website called SourceForge, and all the code would be there. And it felt so great in like 2001 to go to SourceForge, find an amazing open source project, check out all the code to my computer, compile it, run it, and be like, wow, this is amazing. I was able to, compile this amazing open source project and run it myself. That was so cool. And then I could go in and make some small changes, and my changes I could compile and run them. Here's the problem, though. What do I do with all that? Well, theoretically, here's what you're supposed to do, right? You check out the code, and then if there's new changes to that central repo, you can check that out as well, and you can make your own changes, commit, right? Send my changes back to the central server. Well, that's never going to work if you're some random undergraduate or graduate student as I was, working on some project, and I've made some amazing changes. Nobody's going to take my code. And what format do I send them the code in? Do I set up my own centralized server? Well, how are they going to trust random code from like some crazy central server that I've set up? It's hard to negotiate the trust. And so we can immediately see the problems we're about to run into. And just a note about this, like I love that they've got like that these are different little people icons. Like we got glasses, we got curly hair, we got like darker hair, we've got longer hair. I assume that these are meant to represent different genders and stuff, but like they're still all too white and Asian looking. Like we need more. We need to show proper representation for black and brown software developers. Like it's 2020. That's a lesson we have to learn. Like this post is not from 2020. It's from a couple of years ago. But I'm just throwing that out there because you know me. That's the theme I love to hit. So moving on. Centralized server. Check out, make your changes, and then commit back. Immediately we see the problems. Suppose I want to work on like a VS Code plugin. There's a bunch of them. VS Code is the Visual Studio Code. It's the open source editor I use, which is just absolutely fantastic. Or maybe a Minecraft mod. Maybe I want to add something to Wayla or one of the mini maps or I don't know whatever it is. So with a centralized server, I could check out the code, but like they shouldn't accept commits from people that are unknown to the lead developers, right? So I'll set up my own centralized server, and then they'll know who I am. Well, here's a problem with that: it's hard, just because of the way that CVS and SVN work. They're not designed initially to be really web-based protocols. They sort of rely on being able to like have shell access to log into a machine. And there are ways to like enable the web-based protocol, but it's like every developer that wants to essentially check out code from a major open source repository and then like have their own commits that are separate has to like go through this whole process of setting everything up and figuring out like, do I need a firewall, and where's the Linux machine going to live, and do I have a backup UPS for it, and like it's just or if I want to pay somebody to do that, now I have to pay somebody to do this. Now it's not free anymore. So like it's already out of the price range of undergraduates. This is a high bar for new developers to get started. So Git is decentralized or distributed. So we clone the repository, and I'm putting the new terminology in bold and italics. So we clone the repository or repo. Nobody says repository; they call it a repo. That's what they call stuff. So we clone the repo from the central server. And I say central server, we can clone anyone's repo, but in our case, we're going to go to GitHub. Like that's the main thing. We're going to clone that. And that'll be called the origin. And we put that in a local repo on my computer. So now I have a repo right on my laptop, and I can commit to my local repo right away, right? I don't need to do any other configuration. Once I've cloned it, I can make changes to the files. I can commit to it. If new changes get sent to the origin, I can pull changes. And origin is what Git calls whatever, like if you clone something and make your own local copy, where you got it from is considered the origin. It doesn't have to be called origin. You can name it anything you want, but the convention is to call it origin. If you don't call it origin, people might get confused. And once you have permission, you can push your changes back to the origin. But if you don't want to, you don't have to. Like you can still just have your own local repo and commit to that and make branches and do whatever stuff you want. It's a full-fledged Git repo at that point. So here's the sort of simplified view of this decentralized or distributed model. We've got our same set of developers. They're going to go ahead and clone their own local repository. They can commit to their local repo, and if they can pull any changes that show up in the central repo, and then they can push to the central repo as well. So this looks great. But it turns out that Git is more powerful than that. Git does not require that you have only a single origin, right? So the origin is considered what's called a remote repo, meaning it's not your local repo. You can have as many remotes as you want. Origin is just like the conventional name for the one that you initially cloned from. So you don't have to have an origin. You can, you don't have to have a single origin. You can have as many remotes as you want. And then you create these relationships, which are called upstream and downstream. So let me show you this more complicated picture. So this is kind of the same thing, but this developer over here, let's call them A. Let's come up with a name. Alfonso. So Alfonso over here, and we'll go with this person will be B. This will be Brianna. So Alfonso and Brianna have declared each other to be remotes, right? So your origin, if you're Alfonso, your origin is a central server, but you've been like, you know what? I've also got another remote, which is Brianna. And Brianna's done the same thing. I've got another remote, which is Alfonso. So those local repos are now remotes of each other, right? So this means that Alfonso can commit to his local repo, and he can pull code from the central repo, but he can also pull changes from Brianna, and Brianna can do the same thing. She can pull code from Alfonso and also push code to Alfonso and vice versa. Um, so who's upstream from Brianna? Well, the central server is upstream from Brianna, but Alfonso's also upstream from Brianna, and the central server is upstream again, right? Is further upstream. This person down here doesn't even directly access the central repo. This person just has two remotes, which are just the developer's local repos. Boom, done. Why would you want to do that? Well, I don't know. This person might be a tester that only tests new features on branches that these particular developers are working on. Maybe they only work on, highly cutting edge features that require extensive testing. So, we're just sort of testing stuff for like the next release. And so this person doesn't need access to the central repo at all, right? So we can create all of these really cool relationships using Git that would be very hard to do with a central server. So that's what's going on. Another question students often ask, what's the difference between Git and GitHub? You'll often, seems like people are using these terms interchangeably. Of course, they're not the same. Git's a protocol for doing distributed version control, right? So this process of having, remote and having your local and being able to clone and then being able to commit and then being able to push and pull, like Git's the protocol that enables all of that. GitHub's a particular like implementation of that protocol through this whole web service. I say website, it's really a web service that will let you host publicly and privately accessible Git repos. It's important to note that GitHub is not the only website that provides public and private Git repos. Bitbucket does the same thing, and Bitbucket is used to host, any number of important projects. And so here's the particular problem that GitHub solves. I'm going to go back a slide. Whoops. I'm going to go back 2 slides. So if you look at this picture here, you're like, Alfonso's got a local repo. Where's that local repo located? Well, if you clone from the central repo, this is actually a deceptive picture. This local repo is on Alfonso's laptop, and this local repo is on Brianna's laptop. Well, that's kind of a problem if they're going to be remotes of each other. What protocol do you use to access somebody else's laptop? That's kind of annoying. What GitHub lets you do is have a local repo literally on your computer, have a remote repo on GitHub that you cloned, or to use the way it's done on GitHub, forked from another repo on GitHub. All right, so let me explain that again. Here, your central repository, which again, there's not really a centralized repository, but for most companies or most large projects, like there needs to be like a single privileged repository that is like the main repository where like the current release of the software resides. So on GitHub, this would be, whoever the lead developer is or the lead organization, their repo. So what you would actually do, you would have a local repo on your laptop that you cloned. Sorry, let me say this a different way. This is the open source project you're really interested in, a really cool VS Code plugin for doing syntax highlighting for, Clojure or something like that. And I want to add some cool features to that or something. So what I do is I fork it. What does fork do? Well, on GitHub, fork means take one repository on GitHub and make a copy of that for me also on GitHub, right? So this wouldn't really be a local repository. It would be another remote repository on GitHub, but it would be a fork of another repo on GitHub. So both of these would be on GitHub. When I do my clone, I don't clone the original repo. I clone my forked repo. So now my local repo is actually on my laptop. So when I do committing, it's to my local repo on my laptop. My origin is now my remote repo on GitHub, but that is actually downstream. Its origin is going to be the central repo, which was, the main repo of the project. So in this way, these two developers, Alfonso and Brianna, they may not know each other, well enough to be giving each other like some sort of access to each other's laptops. So where are these repos to set them upstream, downstream, remote from each other? Well, it's on GitHub, right? So that's the problem that GitHub solves, and it solves it really, really well. Um, so you can have two different versions of the same project on GitHub at the same time. I can go to your project and be like, this is an awesome project. I can fork it, so now I have a version of your project on GitHub, and then I clone my forked version, and then I can sort of commit and push to that. And so now, as a developer of this main repo, right? If I want to tell you like, hey, look at how good my code is, what do I point you to? I point you to my GitHub repo, right? And you know exactly how to clone that and run it and do whatever. I don't have to send you, a zip file or whatever else I might have to do in the centralized world. Everything's on GitHub. So all the ways that you use it and clone it and compile it and run it, whatever, all that's going to be exactly the same. So that's the really cool problem that GitHub solves and how it implements the Git protocol. Um, one final note: a Git origin story. This is a good article. I had never. I mean, I knew the story. I hadn't read this article. It's a good article in Linux Journal. So Git was actually written by Linus Torvalds, who also wrote Linux. So thanks Linus. Like you could already walk into a room with a bunch of tech people and just be like, oh, do you know about Linux? And they'd be like, yeah, we know about Linux. Oh, that was me. I wrote the original version of the kernel, and I was the lead maintainer of the kernel for much of my adult life. I'm kind of a big deal, right? Linus, you can already do that, and that's not good enough. He goes and writes Git as well, which is now the dominant distributed version control system in the world. So, great. And I make videos, so to each their own. Cool. All right, nerds. Thanks for watching.